Alright, here's a review of factoring and solving quadratics in standard form. It's also going to be a brief review of I. Let's go ahead. Here are 4 problems. This problem and this problem are pulled from your review. This problem here is not, it's simply pulled from a classwork. What I intend to do is I'm going to work problem 13. I'm going to work problem 16 because they're examples of what you might have on your quiz. I will then show the correct work for 14 and 15, but I won't walk through it. After that, I'll have a brief discussion about I and operations. Let's go ahead. Alright, problem number 14, or 13. First, I have to remember that if I'm going to solve, I must have the entire quadratic solved for 0. And so what I will do is I will add 25 onto this side, and I will add 25 onto this side. This allows us to have 4x squared plus 20x plus 25 equal to 0. Now what I need to do is to check for a GCF. However, there is no GCF. So I will continue. I do notice that my a here is not equal to 1. So in this case, what I'm going to do is to bring it to multiply with the 25, and then I'm going to factor apart that product. So in this little workspace, I'm going to take the value of 100, because it's 4 times 25 will be 100, and I will factor it apart. Reminding you what I'm looking for are 2 values that will add to make 20. That's the b value here, and it needs to be a positive 20. So let's factor. I have 1 and 100, 2 and 50. I have 3 doesn't work. I would have 4 and 25. I would also have sorry, I would have 5 and 20. 6, not really, 7, 8, 9, but I would have 10 times 10. I'm looking for 2 values that will add to make 20. In this particular case, we're going to pick the 10 and the 10, because if you do 10 plus 10, you will get 20. So then I'm going to create the binomials I need. It will be x plus 10 and x plus 10. It is important, however, to point out that this is not done, because we cannot multiply this and go back to 4x squared. What we need to remember to do is this value here, we are going to divide by the 4, or divide each of these back values by 4. We then need to remember we are going to reduce them both. This is going to be 5 over 2. This will also be 5 over 2 plus x and plus x. Then we do not leave the denominators because this is still not done. I will take my denominators and move them to the front in both cases. What I will be left with is 2x plus 5 and 2x plus 5. At this point we are factored, but we have to remember that we are solving now. So, need a little more room. In order to solve what we need to do, we must take this part, make it equal to 0. we will also take this part, it is identical, I understand, and make it equal to 0. After I've solved these two algebra problems, I will have my results. So, if I minus 5 from this side, I will be left with 2x to be equal to negative 5. Then, dividing by 2 on each side, I will be left with x to be equal, I didn't even write that, there we are, that's right. I will be left with x to be equal to negative 5 over 2. Now, this is going to be the same exact problem, so I'll have the same exact answer. As you can see, in this case, my x value is going to be simply negative 5 over 2. That is the solution for this quadratic equation. First we solved for 0, then we multiplied. If we looked for a GCF, we then multiplied the a if we had one to the c, factored out the product of a and c, chose what we needed to add to make positive 20, continued remembering that you have to divide, then you must, in this particular combination of steps, reduce and rearrange. Let's look at problem number 16. Similar case. We still need to solve for 0. I see that this term here is on the wrong side. It needs to go over, but I need to pay attention because this is the a term, this is the c term, and this is the b term. I can tell looking at the exponents and the x. So when I am done, this part actually has to live here. It should not go behind the 3, the negative 3. So let's do that. Minus 11x. I'm going to minus 11x. That will leave us in ABC order 4x squared minus 11x minus 3 will be equal to 0. We are solved for 0, and so then we are able to not quadratic formula, but factor and then solve. I do want to look for a GCF. I see that no one can divide into all of these terms, so I understand that there is no GCF. Now, I see that my a happens to not equal 1, so I'm going to take this value of 4, I will bring it across and multiply it to the 3 in order to get a value of 12, which is what I need to factor apart. So I am going to factor apart 12. My goal in factoring apart the 12 is to figure out what can I subtract in order to make a negative 11. Again, the negative 11 is the b value. I want to find what factors of a and c will subtract to create for us a negative 11. So 1 times 12, I have 2 times 6, I have 3 times 4. For this particular problem, if I were to subtract 1 and 12 in that order, 1 minus 12 is going to equal to negative 11. These are the values that I want. Notice that I'm working with a negative 12 and a positive 1. I will now write the binomials. X here is going to be plus 1, x minus 12. This will now be equal to 0. Alright? So again, it's important to point out that this is not complete, because if I were to in fact multiply these two binomials, there's no way I can get here. What I in fact need to do is to remember that I did divide by a 4, and I did multiply by a 4 here, so I have to undo that multiplication. I'm going to reduce this fraction. This fraction will easily reduce to 3. So this is the binomial I'll have at this point. This fraction doesn't reduce, so I'm going to keep it just like it is. Then what I'm going to do is to move this denominator to the front, and I will end up with 4x plus 1 and x minus 3. This is now factored. But that's not what we were asked to, that's not where we were asked to stop. We were asked to go ahead and solve. So in this case, I will need a little more paper. And what I'm going to do is to set each, because I'm equal to 0 here, that's what the original problem says. So I'm going to take this binomial and set it equal to 0. I will have 4x plus 1 is equal to 0. I will also have the other problem, or I should say the other factor, and I will set that equal to 0. And I will solve these. On this left-hand side, I will have minus 1. Then I will have 4x is equal to negative 1 if I divide by the 4. I will end up with x is going to equal to a negative 1/4. On this side, if I were to add 3 to both sides, I will end up with the final result of x equal to positive 3. These are my two solutions. Alright, so what I'm going to do now is I'm going to just work problem 15 and problem 14. I'm not going to explain it much, and just show you what the result will be. Alright, so here are the two problems 14 and 15 worked out. I'm not going to say much about them. Pause the video, look at it, see if you have questions, bring those to class. Alright, continuing on. Alright, a quick review on I. We have to remember a couple of things about this. Here's what we need to remember. We need to remember the cycle of I. So I equals I. So if I take 1, the power on this I, divided by 4, I will equal, that's incorrect right there. That should be 0.25. And anytime I see a decimal of 0.25, that will indicate I. So 7.5 would indicate I. I squared is going to be the power of 2 divided by 4, which would have a decimal of 0.5. That would indicate negative 1. I'm sorry, negative 1. Lastly, you would have I cubed, which is going to equal to negative I. If you take 3 divided by 4, the exponent divided by 4, you would end up with 0.75. That will indicate a negative I. I to the fourth will equal to positive 1. Positive 1 has a decimal of 0.0. We use that to remind ourselves as an indicator that we're looking for positive 1. So we have several problems here. Here, I have I cubed. I take the exponent, 3 divided by 4. That gives me a 0.75. This 0.75 is an indicator that I am looking at negative I. So I can say I to the cube is equal to negative I. Next one, I to the 8th. I take the exponent of 8 divided by 4, I get 2.0. This decimal of 0.0 indicates that I'm looking at the value of 1. So I say now I to the 8th is equal to 1. And on with this. The 0.5 indicates negative 1, indicates negative 1. So I am looking at negative 1. So I have I to the 10th equals negative 1. 79 divided by 4, 19.75. That decimal indicates negative I. So I know that I to the 79th is equal to negative I. And lastly, 469 would create a decimal part of 0.25 that would indicate I, and therefore I'm looking at I to the power of 469 is going to equal 2I. Continuing with this, here I know that I have to get the I out. So this would create I square root 81. We know that the square root of 81 is going to be 9, so I'm going to have 9I. Here the negative is already out, so I don't pull anything anywhere. This just becomes square root of 5. So that's incorrect. This just becomes the value of 5. Square root is gone. So this I am actually finished now. In this case, there is a 4 out front, so I know that the I needs to come out. I will have 4I multiplied to the square root of 45. Now I do know that 45 comes apart into square root of 9 and the square root of 5. Square root of 9 is simplifiable, so this is going to become 3 times 4I square root of 5. The 3 can multiply to the 4 to give us a final result of 12I square roots of 5. This is simply a FOILing problem. Two binomials multiplied together. If I take 3 times negative 4, I'm going to get a negative 12. If I take 3 times a positive 2I, I'm going to have positive 6I. Here, negative 2I times negative 4 gives me a positive 8I. Lastly here, I'll have a negative 2I times a positive 2I. That's going to give me a negative 4I squared. So, several things to recall. 1. Here I see I squared. This is going to become negative 1, which is going to multiply to the negative 4. Secondly, these two like terms need to be combined. So, the total process is going to produce for us negative 12 in the front. 6I plus 8I will give us 14I. And then negative 4 times negative 1 will give me a positive 4. I then have two more like terms to combine. Negative 12 added to 4, I will get negative 8 plus 14I. This is complete. Similarly, this single distribution will give us 15. This one here will give us negative 6I. This is a negative I multiplied to 2. That negative I will also multiply to a positive 3I, creating not positive, but rather negative 3I squared. Notice one more time, this I squared will become a negative 1, which will multiply to the preceding negative 3. Also, these are my like terms. Negative 6 combined with negative 2 should give me negative 8I. This is going to become a positive 3. We're going to bring down the 15. I one more time have two like terms. I should be able to combine and give 18 minus 8I. We are complete here. If you have any questions, bring them to class. Look for the answer keys. See you in class.